Yeah, I want to welcome all of you to my officially, technically, first presentation back after COVID. And yeah, today I'm going to be talking about securing some continuous delivery and continuous deployment pipelines. So if you're not familiar with any of this don't worry. I'm going to give you a little bit of foundational knowledge about all these things. And then midway through, we'll start talking about how it relates to security. And how you can secure some pipelines. So let's start with a quick agenda. So again, just going to intro the topic, which I already did. I'll introduce myself. And then we'll talk about software development lifecycle. So that's the foundational knowledge and how they relate to CI/CD. Then I'm going to jump into DevSecOps, right? So we'll talk about DevSecOps and what that means in regards to pipelines, and then some pipeline integration discussions, and then we'll jump into talking about how we can secure pipelines, and then I'll recap all of that stuff. So my name is Agile Rivera. I'm a developer advocate for circleci, and I started my career off in roughly professionally programming around 1994 for United States Air Force Space Command. So I was actually stationed in Cape Canaveral Air Force Station, and when we used to launch humans, and NASA launched humans on the space shuttle. So my job there was working on what we called aeronautical control officer, which meant I helped keep the airspace clean and green of all obstructions, right? We don't want to be launching things and then hitting aircraft while it's transiting up to orbit. But while I was there, I caught the programming bug professionally. I had been programming as a 13-year-old, 12-year-old, right? The old school days of like really slow modems and stuff like that, bulletin boards. So I kind of grew up in that era of programming things at scale, which is a very unique perspective. So as a developer, a young developer, I always wondered where my code went, right? Like after I wrote it used to be like Kat in her presentation showed a floppy disk, right? It was either, drop your changes into a network share, and some operator, sysadmin type person would pick it up and then deploy it with a patch or something later on down the road, which could have taken anywhere from, a 1 month to 3 months, depending on whatever QA process, security, all that good stuff was happening. Anyway, fast forward to today. I've worked in the federal government for about 11 years on top of the military, so I got to see, again, things being built and operated at scale, which is really important, especially for folks who are just kind of tapping into this industry. So I want to share a little bit about history of how we used to build software and how we're building it today, and then how all of these new concepts kind of come into play, and then how we can secure these things. If anybody wants to reach out to me, please hit me up on Twitter. I, like Kat, am not a big fan of email because we're traveling so much these days and doing other things. The quickest way to get my attention is through that little Twitter bird, right? And send me a tweet and we can have conversations about leather bags, CI/CD, space shuttles, whatever you want to talk about. I'm pretty much open to it all, so cool. So yeah. I would really, really appreciate, this is a new thing that we're doing at circleci for our developer advocate team. If you could all just send me some feedback on this talk. I'm open to all criticism, constructive criticism. And if you do, Jeremy, correct me if I'm wrong, we'll send a swag pack of, so we have some special circleci swag that if you all want. And again, I want to make this talk, valuable for folks. So any constructive criticism is we want it all. So just please submit it. So let's talk about software development life cycles, right? Raise your hand if you're familiar with SDLCs. Okay, cool, that's good. We're going to talk about software development life cycles, and like I said, I'm going to give a little foundational knowledge about a little bit about the history of software development. And by the way, this is from Angel's perspective, right? So if it's similar or different, that's okay. It's just kind of giving you my take on it and from my lens. So software development practices, right? Software development life cycles are basically the way that an organization, team, or developers build software, right? It's just some rules, guidance, whatever you want to call it, procedures, that we use to build our software. When I was coming up in this business, Waterfall Development, which is a practice of, or a version or a flavor of software development, was really popular, right? It was actually, I think, the only way that we were building software because all the other methodologies weren't kind of on the scene. And even within waterfall development, it varied. So the general concept is waterfall development, if you can see from this graphic, right? It was all kind of a cascading type of development. Now, again, if you've had this experience with waterfall in the past, this may not be exactly the same, but this is the general pattern that we saw. So you would develop some requirements, and then the stakeholders would push that down to the development teams, and then those tasks were doled out. One of the inefficiencies that I experienced and I really hated about waterfall was they would just give you all of the tasks, right? It was like, here, build all of this, and it would be incumbent upon the individual to build out these things. And in general, we didn't really collaborate with each other that much as, kind of building things in isolation. And that was part of the inefficiency is, number one, in waterfall, every task is dependent on the previous task being completed, right? So like, you could imagine if I finish something in a week, but I'm waiting on Bill over here to finish his thing that took him a month, it's a problem, right? Like, I'm just sitting around. It's not like you can just grab another task. I mean, of course, we broke the rules and, kind of did our own thing and figured out that you could do it, but there was a lot of communication involved, and all that stuff. But it's still very inefficient. So, as engineers, right, we realized later on down the road that we can do this a lot more efficiently. And that's where kind of the smarter heads in the industry came together and said, all right, let's build software a little bit faster. And they gave it a name, right? Agile. And that's based off of lean theories and concepts, which were actually used in automotive industry, right? So, there's a little bit of that kind of mixed in, those concepts mixed in to this whole agile development process. And this is what agile looks like, right? So if you can see, right, it's no longer a cascading kind of interdependent system. It's pretty much everything's happening at the same time kind of concept, right? So that's how you gain those efficiencies, but it's being controlled. One of the main components of Agile is breaking tasks into smaller, more manageable pieces, right? So developers are no longer given this here big list of things to do and then waiting on Bob or Bill or Susie, whoever, right? You're actually working on smaller incremental things, and then you're submitting those changes you made to that sprint, right? In the center circle, right? The people who are managing all of those things. So that makes things happen a lot faster, right? So again, we're doing things concurrently in smaller increments, and it's way more manageable on the individual level versus, just trying to do massively management of all those changes, right? So again, just you notice all that movement happening, right? And they're happening all at the same time in different areas, but at the end of the day, they get centralized again in the sprint, in that center circle. So after we figured out Agile, let me get rid of that. After we figured out Agile, right, and saw the benefits of the efficiencies, then the industry got smarter and said, wow, okay, so now we have, this software methodology that we can build. We know how to build software more efficiently. We need to apply this now to our delivery of that software, right? Releases. So, of course, again, smarter heads in the industry came together with this concept of continuous delivery. And all that really is mimicking, right? It's a concept, right? These are concepts that kind of mimic the Agile process, but on a grander scale. It also includes, right, getting all your code changes from A to Z, including deployment, right? And even, I would venture to say, observability, right? So we're watching, after things are deployed, we're watching those changes and ensuring that they're behaving the way that we spec them out to, right? So with continuous delivery, again, if you think of it as an overarching concept, right, and it's actually closely tied to your agile development practices or your waterfall even, right? So from that, there's a concept within that, which Kat talked about. I know there's a few folks that came to the CI/CD, the history of CI/CD talk earlier, and she had a little bit of an issue with, continuous integration, continuous deployment. She had mentioned in that talk that the CD has two meanings, and she was saying that it was continuous delivery and continuous deployment. I don't have that problem because I consider continuous delivery as an overarching concept that CI/CD is nested into, right? So for me, the CD is continuous deployment. And I think in general, the industry agrees with that. But there is mixed opinions on it. I'm in the CD camp, continuous deployment camp. It just makes more sense to me, right? But again, these are the concepts of kind of building software in this new modern age. So it also ties really nicely with DevOps, right? So who here has heard the term DevOps, right? And who here knows what the term actually means? It means a lot of different things, right? It's supposed to be a cultural thing. As our industry does, it capitalized on buzzwords, right? And kind of made us think that, oh, well, it also means, bridging developers and operations together, and developers and operators will live a happy, hunky-dory life. That's not the reality, right? At the end of the day, I think it works for some teams, those kind of approaches work for some teams, and others it won't. My opinion and my definition of DevOps is where you can, basically it's focusing in on the points of handoff in software changes, smoothing those transitions out so that they're more collaborative, the increase the coordination between the teams, and not necessarily making a developer do operational tasks, which in most cases they don't want to do that, right? Like front-end people are not interested in deploying their beautiful applications and their beautiful work in an AWS serverless thing or whatever, right? Whatever that mechanism is. They're interested in finishing that and making sure there's no bugs in it, and then going back and enhancing, right, their art. Because at the end of the day, if you're talking about front end, most people I know, designers, they're artists, and they consider that work art, right? Whereas in operations, folks, they're totally down to take that art and then see how it can scale, right, under load and operate when millions, hundreds of millions of people are using that. So again, with CI/CD, these are concepts, but they blend nicely.
All right. So we'll just stand here. All right, so develop these processes, external to any kind of tooling, right? And I'm talking, there's no tooling involved here. This is just kind of standard operating procedures, right, around writing code. And obviously, the concept here is a test code on every commit so that you're getting consistent, reliable code and understanding what's happening with those changes. And my favorite of all is the fast feedback loop, right? Understanding when you have a problem, and then being able to quickly fix that, right? So that goes back to kind of like that agile system where you're doing small incremental works, and then you can see hey, I've got a problem maybe with a semicolon that I forgot to change or whatever. It's better to catch that up front instead of continuing to put that semicolon where it doesn't belong and then having 1,000 broken pieces versus fixing it in 1 to 10 places, right? So that's the conceptual principle of continuous integration. Now let's talk about continuous deployment. Similar thing, right? You're creating release artifacts for your deployment processes, and then obviously you're deploying those to target resources, right, or environments. Kubernetes, could be a Apache server, a Tomcat, whatever you're using, doesn't matter. And then your post-deployment, right, you should be validating those applications and services and ensure that they're functioning the manner that, that you spec'd out. And then obviously, right, you want to monitor this stuff and then also have in the back of your mind as a goal, verifying the state of the app, but also having some sort of resiliency or recovery type functionality, right? So that you're not there manually doing all these things. It's a real pain, right, to recover systems. They should be, we're at the age where, we have a lot of organizations and services that are perfecting the art of resiliency, like chaos engineering is another concept, right, that can be applied to these things. But I would say, if you're not there, that's okay, but start looking towards that. So all of those things I described, continuous delivery, continuous integration, continuous deployment, these are all concepts, right? These are the way we should be operating. And none of that stuff actually happens until you add automation, right? So remember, we're aligning our software development practices. We're creating that alignment with our continuous delivery processes, our continuous integration, deployment processes. Automation is the last ingredient to actually, facilitating all of these things. And, when you add that automation, the general term for like executing this stuff in automation is called a CI/CD pipeline. That's where circleci comes into play. Like, we produce a platform that we meet developers where they are. So before I described all of that stuff, right, about, how we used to build software, and I used to throw it over to my sysadmins or SREs or whatever you want to call them today, operators, and they would deploy code. In this case, you can actually leverage circleci, the automation, to actually build CI/CD pipelines. And this is just a little example of what a pipeline looks like in our dashboard, right? And as you can see, there's a lot of things happening here, right? But at the end of the day, this pipeline is used, what I use it for is to what I call increasing the app's confidence or releases confidence. So the idea here is to build my application. I run some unit tests, right? Make sure that everything's hunky-dory. And then I create, using infrastructure as code, Pulumi, Terraform, whatever, to build a Kubernetes cluster, build a Docker image, and then I deploy it, right, to a brand new Kubernetes cluster. And all I'm doing here, and then I smoke test it, meaning, run a quick test. Does this work? Does it respond the way I want it to? And when it's all said and done, it's just another check in a box that tells my release team, hey, this has been deployed and tested in a Kubernetes environment. So all those questions are pretty much out the door. And if you're doing configuration validation, right, because Kubernetes requires a lot of configuration, then you can run tests on those. But at the end of the day, this is just what I call a smoke test, right, for that build. And there could be a pipeline that continues, right, and says, hey, deploy this to production or QA, whatever, however you operate, that's okay. But this is just a good example of a CI/CD pipeline and how all of these things happen, right, and how they're all tied together. So now that I've got you all informed and a good foundation on all of those continuous delivery practices, let's talk about DevSecOps and pipeline integrations. So is everyone here familiar? Raise your hand if you're familiar with DevSecOps. And yeah, cool. For those of you that are not, DevSecOps is essentially DevOps, right? And I will say this, DevOps has always had a security component to it, but it wasn't that popular. And I think it's because a lot of the engineers wanted to just get something out there, get this concept out, right? Get people thinking about building and deploying software in a certain way, in a different way. But it was always built into the conversations, and it's always built into the concept, but it wasn't highlighted. Now that, it's like everything else, right? When things get better, these new things, concepts get better over time, then things that were deficient in it are starting to become more and more visible, right? And surface security was one of them. So the concept of DevSecOps essentially means you have a process or a job in a pipeline. A job is just a grouping of commands that achieve a specific goal. In my pipeline, I had build a Kubernetes thing. That's a job, right? Build a new cluster, whatever. In this pipeline, you see in the middle is a little lock, right? And that's scan for vulnerabilities. So now, right, you're able to do those things from the pipeline. So the concept of shifting security left, has anybody ever heard of that here? Yeah. So all that really means is you have that lock sitting in a pipeline, right? So some pipelines, most pipelines I see, don't even have this security type thing, right, happening in their automation. But what all that means is now, as developers, and I'll give you a quick story. Like when I was coming up, the security teams in my organization, I would write code, send it over, like I talked about earlier, right, to my ops team. They'd kick it back, deploy it, kick it back, and say, hey, this is not good. And it would just take so much time. And then finally, we got everything nice and tight. And then right before deployment, the security team would get a hold of it and go, oh, this is terrible. You have like all these issues. And as developers, at least back then, I think it holds true today, we're not security experts, right? We're just writing code. Now, fast forward to today, there's a lot of tooling out there now that we can easily implement and tell us, right before we even kind of ship it off into our rest of our team, that you got issues. And that's what security, shifting left security means, right? You're just moving that function from the left or the right of the pipeline, right, at the end of that operation, all the way to as far left as you can, right? And with CI/CD and CI/CD tooling, you're able to create those jobs, scan for those vulnerabilities, and ensure that, your dependencies in your open source stack, right, are like legit safe and not vulnerable. And by the way, with these tools, the developers now don't have to even deal with security right off the bat. And that's actually good for security, right? So they can focus on the things that matter to them versus, and things they're not even experts in, right? Like if you send it off, most security folks are just going to kick it back and say, hey, developers, you need to update, well, actually, they don't even say that. They just say, do these things in a mitigation list from one of those tools, right? So what we've done is just automated using those tools, and developers are actually learning as well, right? So now we weren't security experts, and no developer wants to write insecure code, right? Raise your hand if you want to write insecure code. Nobody here wants to do that. But now we're educated, with using the tooling, just makes that education a lot easier for us, right? So if we're told, hey, this vulnerability, and told exactly what to fix, we're going to fix it. And by the way, we can also test those changes, because a lot of those dependency changes, this used to happen to me a lot too. Security would take it upon themselves to just do the mitigation without consulting, and it would just, we didn't update that dependency because there's a problem with backwards compatibility or, some deprecation that happens. So they're not developers. They wouldn't know that. Same as us not knowing about the security, right, problems. So this just helps in that world, right, in that space. And that's what like DevSecOps is all about, and shifting left. So now if you hear that term, and by the way, they're using that term not only in security, it's like a lot of processes, right? Like even in operations, they're shifting left. So that's all that means, is just moving that functionality to earlier in your pipeline. So with shifting left, right, that's just one little kind of thing to look out for in your security, in your CI/CD pipelines regarding security, right? Getting all those vulnerability scans out of the way, and obviously you're integrating these actions into your pipeline, right? And then you're able to do things like pipeline security scans, like I mentioned earlier. You can do you can build application scanning. This should be jobs, not pipelines, but you could do pipelines that only do that, whatever, right? Whatever the flavor of process that makes sense for your organization. You could do static analysis, app scanning, making sure your code is actually in line with some sort of requirement, right? Compliancy. You can do container vulnerability scanning, which is really, really big now, obviously, right? With things like Kubernetes and container management and serverless functions that use containers. You definitely want to make sure that the application is the scanning of an app, security scanning of an application is way different than a container, right? Because that's more of an environmental scan. And there's different vulnerabilities in containers, right, that are not related to your app. So just think about those things totally different. Even though your app is the focal point, the container has extra layers that you need to look out for as well. So now that we talked about DevSecOps and pipeline integration, let's talk about securing our pipelines. Now, this is a very vast topic. I could tell you how to do a bunch of different security actions, but we only have a few minutes, so I won't do that. But what I'm going to talk about is integrations and secrets management, right? How just one sliver of a pipeline. But I think it's a pattern that we all do in our pipelines, or we aspire to do. So let's talk about pipeline integrations. There are many multiple ways we integrate, right? So CI/CD pipelines, actually our whole software stack, our solutions are now integrated. The whole world now in software is connected in some way, shape, or form. And it's becoming more and more prevalent in the area of we're connecting to third-party tools and services, right? So these things are just like machine services talking to other machine services. But they require integration types. So when you have integration types, such as, right, app code coverage tooling, you have integrations into API requests, right? Like I said, we're calling different services, database access, cloud provider, CLI tools. These are all things that, happen within a CI/CD job. But all of these integrations require access, meaning they need to, gain a certain level of access to a service or a tooling, or you need to authenticate, and they require credentials. And these are just a list of the types of credentials that you would need in certain, depending on what you're doing. But they come in many flavors, right? But at the end of the day, they're just credentials. And the way you retrieve them from a service or authenticate a service is completely different. But you got stuff from OAuth all the way down through to regular old username and password, right? But I just wanted to kind of show the different access credentials. But I'm going to call these credentials secrets for the purposes of this talk. Because, what we're talking about here is sensitive data, right, at the end of the day. Whether it's a password or a credential, or if it's bank account information or PI, it's all sensitive data, secrets, right? It's supposed to be maintained secret. So these secrets obviously provide our access. And if you don't secure pipelines, right, your CI/CD pipelines, those secrets can be just as easily exploited as if you just left your username and password on your monitor in your office. So working with a ton as an integrator, that's all I've done most of my career. One of the main culprits in incidents is weak and stale secrets, right? People have very weak secrets, or they don't change their secrets as often as they should. You have unmasked and unencrypted secrets that live in systems and configurations, right? That's a huge problem. And it's no different in CI/CD pipelines, right? And that's where I'm here to say that I would highly recommend that you look into secrets management, systems and tooling. There's plenty of them out there. But definitely look into that, because that will help you protect your secrets, right? And you can automate a lot of that interaction between your services. That you can create strong random secrets, right, that are not created by humans. So no longer are you trying to create something that you can memorize or get in. You shouldn't be doing that. We should have systems that can just generate these obscene length and character type secrets and encrypt them for us, and then also auto-rotate them for us, right? Change, maybe set a policy. I want my secrets to change every 15 minutes. And by the way, the human doesn't need to know those secrets, right? The system does, but the human does not. So if you employ a secrets management system, all your services just need to call back, or your secrets management system is just changing those credentials out, right? Now, when you need to access things manually, then that's when you would go to your secrets management system and say, hey, give me some creds that I can use, right, to debug or do things like that. But those secrets management systems also help with granular access control. So now that you've kind of centralized that access, you now have way tighter logs and audit, right? So if you're in a highly regulated industry, you definitely have the requirement for audit logs and making sure that you know exactly what's going on with those systems and those credentials at every given moment. So again, just get the audit capabilities, and that really helps. It actually helps security, by the way, right? And also compliance officers. It just streamlines all of those things, and it helps avoid any kind of it helps in deterring like incidents, right? That are like vulnerability type incidents. So that's basically it. Secrets management, right? Employ it if you can. I generally don't like to, advertise different products, but I will, since it's an open source project. HashiCorp has a system called Vault. Check that out if you want to play around and set up a system. If you're not familiar with secrets management, definitely check that out. Make sure that you get a handle on it. They have a nice implementation that will. And again, there's multiple products out there, but I'll give HashiCorp some love there on that one. So recap real quick: CI principles, continuous integration principles. Write and commit your code off into a shared repository. Test your code on every commit. Fast feedback loops. Fast feedback loops. Make sure that that's part of the system that you're having, and it makes it super easy for people to get notified when there's a failure in your code. The continuous deployment principles, right? You want to create your release artifacts, deploy those code artifacts. Now, again, you could do this manually. You could do this using the continuous delivery platform like circleci. I like people, want to kind of tell you kind of like best practice. I hate that term. I think it's whatever practice works for you, but you should always have an aspiration, right, to automate as much as you can. Sometimes we're just not in that position to do it. We don't have the experience, we don't have the staff, we don't have maybe even, our management's buy-in. Just do what works for you, but always have an end game, right? Like, or an innovation goal, right? You want to, hey, let's just deploy one app, whatever. At any case, just do what's best for you, and then hopefully you can evolve eventually, right? And then validate your apps and services. Make sure where you can add some sort of resiliency to your processes and your deployments, as well as helping recover from failing situations or services are failing. DevSecOps, shifting security left, right? Employ tooling that helps your developers and your operation understand the security landscape a lot better, and offload some of those tasks to the automation so that your security teams and your development teams are not bogged down by that stuff, but let the tooling do the work, and then you handle those exceptions, right, wherever possible. Scan your applications, your containers, right, and then eliminate all those artificial domain barriers, meaning, transition that work amongst the teams. Work on focusing on that, right? Enhancing those transitions and streamlining them so they're not a barrier. Securing your pipelines, just implement a security management tools and policies. Integrate these tools into your pipelines wherever possible, and they will help you with the strongly generated passwords, secrets, credentials, and then help also with auto rotation, right? So that your time to live on those credentials are as low as possible for your organization. That's it for me. If you could all, again, let me just get to that feedback slide. I would love some feedback. Sorry, I thought I had one at the end, but obviously I didn't. Please, it's just circleci.com/angel, and we will hook you up with some swag if you're interested. But again, thank you all for listening to me. I hope I wasn't as rusty as I thought I was, but it felt real good. Thank you again. Enjoy the conference.